All right, so this is the second period video. This is the odds on the review. The other video posted will be the evens on the review. Okay, the average rate of change. Oh, that's going back a little bit. Average rate of change. Forget the rest of the problem. What's average rate of change mean? Slope. Be a little more specific. Change in y over change in x, or like algebra slope. Not like calculus slope, where we take a derivative, but delta y over delta x. So this is an Algebra 1 question, kind of disguised as a calculus question because of the words that we picked. So from 0 to 3. So I need h of 3 and h of 0, and then I'll just do good old Algebra 1 slope from there. H of 3, 3 to the 4th. 3 cubed is 27. Times 3 is 81. 81 minus 15. I could do some safe stopping in here, except that it's multiple choice, so I'm going to have to simplify everything. 81 minus 15, that would be 66. Yes. H of 0, well, there's an easy one, is 0. So 66 minus 0 over 3 minus 0 would be 66 over 3, also known as 22. And you can see where the 66 came from. I don't know where those other things came from. So answer choice C. Main point of that one, though, was average rate of change means algebra slope. Don't take a derivative. I wonder if that's what some of those answers are, is if you take a derivative. But that would be a instantaneous rate of change as opposed to an average rate of change. Speaking of, number 3, instantaneous rate of change. That's dy dx, that's f prime, that's calculus slope, all those words for instantaneous rate of change. We want to know where that's equal to the average rate of change. Oh, we get to do both then. So I want to know where that calculus slope is equal to the algebra slope. Okay, well the calculus slope, that's easy enough. That would be 6x squared minus 4. So sort of set that aside, go do the algebra slope now. This is a long question. F of 2. 2 cubed is 8. 16 minus 8 is 8. F of 0 is 0. So the algebra slope, I'm just using m to differentiate here, would be 8 minus 0 over 2 minus 0, also known as 4. So the question is, where does the instantaneous rate of change equal the average rate of change? So where does 6x squared minus 4 equal 4? So 6x squared equals 8. X squared equals 8 over 6, or 4 over 3. Square root both sides. And we don't have to simplify square roots. We don't have to fix square roots in the bottom. So I would leave that as my answer, except that plus or minus. This is a tricky one because there's like 2 except that's. Take the square root of both sides, you get plus or minus. Good. But this says on the interval 0 to 2. So not the negative one, or not the negative answer. That one's out. So just square root of 4 over 3. It's kind of a tricky problem because some people will get it right, not because they understood the interval part, but because they forgot to do the plus or minus. So yeah, obviously you can simplify that. 2 over square root of 3, or 2 root 3 over 3. All of those are equivalent answers. And any equivalent answer is acceptable. Number 5. slope of the line, tangent to the graph. Fancy word for take a derivative. At pi over 6. Derivative of tangent is secant squared. Oh, I like that they gave me both of these because they kind of go together. If the derivative of tangent is secant squared, then the derivative of cotangent is negative cosecant squared. And I mean, I really don't know the derivative of cotangent without first thinking about the derivative of tangent. So I like that they're both there. Okay, now I get to plug in pi over 6. Secant of pi over 6 squared minus cosecant of pi over 6 squared. Let's see. Secant goes with cosine. Cosine of pi over 6 is root 3 over 2. So if I flip it, it's 2 over root 3. Cosecant goes with sine. The sine of pi over 6 is a half. So if I flip that, I get 2. And then square it. So 4/3 minus 4, which would be 4/3 minus. As a safe stop, I could have. Well, actually, as a safe stop, I could have stopped all the way back there, but not an option. 4 would be 12/3, so negative 8/3. Always reassuring when you get an answer that's one of your answer choices. Number 7. Hey, what rule am I going to need for number 7? I don't think it's the chain rule. I think it's the product rule. And it looks straightforward enough, so I don't think I'm going to write f prime and g prime separate and then piece them together. I'm just going to do it on the fly. So the first one is x to the 8th. The derivative of secant is secant tangent. Plus the other way around. So the second one is secant of x. And the derivative of x to the 8th is 8x to the 7th. Now, it's not guaranteed that my answer is in that order, but hopefully I can find an answer with all those pieces. Answer choice A is if you just take the derivative of each piece, right? But you can't do that. You got to use the product rule. Answer B looks similar, but someone didn't know what the derivative of secant is. Here we go. Answer C, it's the same as what I got. They've switched some things around, but I think that's right. And I don't know what D is, but it's answer C. Number 9. Oh, here we go. Derivative of cosecant is negative cosecant cotangent. Well, so I'm down to C and D. I think I need to rewrite that first part as x to the, what power would that be? A 7th root in the denominator. Negative 1/7. So I'm not going to write the rest of it because I've already figured that part out. So the derivative of that would be negative 3/7 x to the 1/7, negative 1/7 minus 1, negative 8/7, and that would be why there's an 8/7 in the bottom for answer choice C. And you can see if somebody did 1/7 minus 8/7, or you can see where the 6/7 might have come from, but that's not right. What rule will we need for number 11? That's definitely the quotient rule. Derivative of cosine is negative sine. Derivative of x to the 6 is 6x to the 5th. Yes, again, you can always avoid the quotient rule if you want to write it as x to the negative 6 times cosine of x and then do the product rule. Yes, you can do that. I think I'm going to stick with the quotient rule. But yeah, you can do that. You'll end up with needing a common denominator, and it might be a little more work algebra-wise to do that. So I'm going to go with the quotient rule. Got to keep the GF first. So negative x to the 6 sine of x minus the other way around 6x to the 5th cosine of x all over. What happens when I square x to the 6th? X to the 6th squared is x to the 12th. I don't see an x to the 12th on the bottom, but that's because I could reduce everybody by x to the 5th. So negative x sine x minus 6 cosine x all over x to the 7th. Well, that wasn't as helpful as I thought. They've all got x to the 7th in the bottom. They're both negative. Okay, here we go. D's out, C's out, B's out. A, that looks a little bit tricky. Did you see what they did from answer A to what I had written? Put that negative out front. A little bit of an algebra thing there. But again, the hope is you get close enough to the answer on your own that you can recognize from the choices. 13. Find the slope of the line tangent to the graph. Again, that's a derivative. This one, Addie, I might be tempted to go to avoid the quotient rule. Because you could rewrite it as 2x minus 3 to the negative 1. But, I don't know. F prime is 0, so that'll make some things easy. G prime is just 2, so yeah, this is not a difficult quotient rule problem. Let's see, GF prime would be 0, minus FG prime is 4, over G squared. When x is 4, so I got to plug in 4. So 8 minus 3 is 5. 5 squared is 25. So answer choice C. So yeah, I would say that one was definitely easier using a quotient rule rather than trying to rewrite it. Oh, 14 is not on my list of odds, but while I'm here, that sure looks like the definition of a derivative. That looks like the derivative of sine at pi over 6. Right? So don't work it as a limit problem. Realize what they're trying to get at, the concept, and then take the derivative of sine and plug in pi over 6. Number 15. Ooh. How do you want to do 15? It's actually an option here. We could do chain rule. 5 times all that to the 4th times the derivative of that. Or we could put the 5th on each one. Still have to do the quotient rule. I don't know. Let's just do chain rule. 5 times x over x plus 1 to the 4th. Kind of surprised that's not one of the answer choices. Oh, it is. That's answer choice C. It's not right, because we didn't chain that onto the derivative of x over x plus 1. Okay, quotient rule. Both derivatives are 1, so that'll make it decent, I guess. Okay, gf prime would be x plus 1 minus fg prime would just be x over g squared. That's not bad. The x's cancel. So I've got x to the fourth in the top, and then this is kind of weird. How many x plus 1s do I have in the bottom? 2 there. How many here? 4. So total, there's 6 x plus 1s in the bottom. And that makes answer D makes sense. Okay, that was kind of ugly because it was a power rule, and then after that, use the chain rule, and then some algebra to clean things up. 17. An equation of the line tangent to the graph at the point. What rule am I going to need for this derivative? Oh, well, there's 2 of them, I guess. I'm going to need the product rule, but I'll also need the chain rule for the derivative of that piece. So f prime is 1. This would be one where I would write out the pieces even for the product rule, because that g prime is kind of complicated. Bring the 3 down front, decrease the power by 1, then take the derivative of the inside, which should be negative 2. Let's clean that up first. So negative 6, 1 minus 2x squared. Okay, now back up. Product rule. Fg prime, so negative 6x, 1 minus 2x squared, plus the other way around, which would just be 1 minus 2x cubed. And I want to plug in 1. So negative 6 times 1. 1 minus 2 is negative 1. Squared is 1. 1 minus 2 is negative 1. Cubed is a negative 1. So negative 6 minus 1 is negative 7. So there's my slope. And fortunately, there's only one graph or only one equation that has that slope, so I don't have to do the rest of the problem.
Whenever you did plus for the derivative, you can do the negative 1 minus 2x to the third times x. And then g prime times f.
It sure is, yeah, I don't know what I missed, so it should be g prime times f. Fortunately, that didn't change my answer, because x is 1. It's nice when you can make a mistake and not have it affect anything.
And the cubed in the initial equation only affects the 1 minus 2x because only that is in parentheses.
Correct. The cube is only going to the 1 minus 2x. Yes. So that one, I mean, it's kind of ugly, but it's not as bad as it could have been because there was only one line that had the slope of negative 7. Last one. Timing is perfect. If f is a differentiable function and y equals cosine of f of x squared. Oh, this is like chain rule, chain rule, chain rule. So the outermost would be cosine. So derivative of cosine is negative sine. And then leave the inner stuff alone. And then the derivative of f. I don't know what f is. So how do I represent the derivative of f? And look at your answer choices for some hints there. Yes, f prime. I don't know what f is, but neither do they, so f prime looks like it's an okay thing to write. Leave the x squared alone, because we can only do one layer at a time. And then the derivative of x squared would be 2x. And then it wants me to plug in 3. So y prime equals negative sine of f of 9 times f prime of 9 times 6. Okay, well, in a different order, that would be negative 6 f prime of 9 sine of f of 9. I think that would be answer D. I'm betting anything that that's an old AP problem, because that looks like the kind of thing they do. That's a three-step chain rule where you know two of the functions, but in the middle is a function you don't even know, so you just have to write f prime. Okay, so we got through all the odds. If you want to see the evens, I will post them later.